Morning to every one of you in here. So we are going to continue our lecture today with the second part of the vector value function. That is, we have the line integrals, the Green's theorem, the Stokes theorems, the Divergence theorems. That is a vector calculus. Okay. So previously we have taken a look into the theoretical or the introduction of what is vector value function, how you are going to deal with the vector value function, mathematical operation on the vector value function. What does it mean by having the cross product and then the dot products and so on and so forth. Okay. So today we will continue with the part of the vector calculus, that is the vector value function. Okay, all the theorems that you are going to take a look in today. Okay, so the contents, you are going to have the line integral, the conservative vector fields, the Green's theorem, the surface integral, the Gauss theorems, and also the Stokes theorem. Okay, so what does it mean by line integral? The line integral is a single integral over a curve in three-dimensional space, and it can be interpreted as the area under the curve is space. Okay, an important application of line integrals is the computation of the work done as a variable force that move along an arbitrary path. Okay, meaning that rather than finding the volume and also the what we call it area of the vector function, we can also make use of the line integral to find how much the work done as a variable of force that move along an arbitrary path. Okay. So the idea of the line integral is actually based on the same that we have learned in chapter 2 by finding the integration over the curve instead of integrating over an interval of a from a to b. Okay. So it involves the scalar fields or vector fields. So we will take a look into two examples for this part. That is, we have the scalar field and also the vector field for the line integrals. So we will solve by using the line integral normally used to solve problems involving the fluid flow, the forces, the electricity, and the magnetism. Okay, so you are going to make use this one in the part of vector function dalam chapter dalam subject EMT. Okay, so the definition, let's see, be a smooth curve in two spaces given parametrically by the equation of x equal to function of xt, where t normally represent the time, y equal to function of t, and t taking the value between a and b. And let the function of xy and gxy be continuous on some open region containing the curve C. So from here, we define the integration of the vector function f over the curve C with respect to x. It will be equal to taking the integration from a to b for the function f of xt, yt, x prime t. So gantikan x dan y, we will substitute the x and y here with function of t, because x is a function of t and y as well. It is a function of t, and dx will turn to be x prime dt. Okay, so dapatkan the first order derivative of x because x is a function of t. So from here we do the integration from the curve C. Okay, from the curve of C turn to be the integration from A to B. Why from A to B? Because t taking the value from A to B. Okay? That is why we take the line integral from t between A to B. Okay, and if you have another function of g, and we want to find the integration over the smooth curve of C, but this time around it will be with respect to dy. Okay, So y also a function of t. So it will be equivalently equal to taking the integration for t between a to b for g function of xt, y is function of yt, multiply with y prime t. Okay, so we do the integration with respect to dt in this case. So from here, this is the line integral, meaning that kita ada we have x is function of t and y is function of t and t taking the value in between a to b. So kita nak cari integration over the smooth curve. Okay, kali ni dia bukan satu integration under the area or in the solid. Okay, kita nak cari over the smooth curve C. Okay, that's why you do the integration with respect to C. Okay, so from here integration of fxy dx, it will be taking the integration from a to b, f of xt yt x prime t. Okay, substitute over here for y and g, for f and g function, and xt will become x prime t. Okay, finding the first derivative of vector x and also vector of x and also y. Okay, because it is a function, that's why we can find the derivative of the given function. So from here, the next one, let's say we have this example. Okay, evaluate the integration over the curve C for 2xy dx plus x squared plus y squared terhadap dy. So if you take a look into this one, dia ada dua dx dan juga dy, and the integration is to the smooth curve of C. Okay, over the circular x of C given by the equation. This is your equation of xt equal to cos t. Okay, and then we have this is the equation of x of t, and then we have the equation of y of t. Okay, yt sama dengan sin t, xt equal to cos of t, and t taking the value between 0 and pi over 2. Okay, so kalau kita lukis, let's take a look. This is the question, how we are going to tengok dia punya curve C. Okay, so I want to change to my iPad for this one. How you are going to solve for the line integral. Okay, share screen. Okay, this is the example yang kita nak buat. Okay, so you were given integration over 2 xc. Okay, integration over the curve C for 2xy dx plus x squared plus y squared dy. Okay, so from here we want to do the integration for this given function. Okay, so if you take a look at this one, macam mana kita nak define dia adalah integral. Bila awak tengok for this example, contohnya, okay, for this particular example, dia punya integration adalah terhadap curve C. This one, okay. And you have 2xy dx x squared dy. So it will be integration over the curve C, 2xy dx plus integration over the curve C, x squared plus y squared dy. Okay. So awak punya x of t equal to cos t and y of t equal to sin of t. So t taking the value between 0 sampai pi per 2. So macam mana kita nak buat the drawing of this function. Okay. So t sama dengan 0 sampai pi per 2. Okay. So x sama dengan cos t. So when t sama dengan 0, x akan sama dengan cos 0. So dapat apa? Okay. When t sama dengan pi per 2, x sama dengan cos pi per 2. What do you have for the value of this one? Cuba buat sekejap. Bila t sama dengan 0, okay, akan dapat cos 0 sama dengan berapa? Oi, cos 0 berapa?
1 doktor.
1. Okay, asal aku tak dengar suara kau? Cos 0 sama dengan 1. So, cos pi per 2? Kosong. Okay. Awak dengar suara saya tak?
Dengar doktor.
Dengar. Saya tak dengar sangat suara awak. Dia keluar, dia tak keluar dekat earphone, dia keluar dekat komputer. Pelik ni. Internal mic and speaker. Okay, cuba cakap seorang. Hi.
Hai.
Baru dengar. Okay. So, in this case, y pula sama dengan y sama dengan sin t. Okay. So, y akan sama dengan sin 0. Okay. Dapat sama dengan 0. And this case, y sama dengan sin pi per 2 dapat sama dengan 1. So, kita tengok bila t sama dengan 0, awak dapat x sama dengan 1 dan juga x sama dengan 1, y sama dengan 0. And when t sama dengan pi per 2, x sama dengan 0, y sama dengan 1. So if we do the drawing here, this is your x, this is your y. So dia akan ada titik 0, 1 dan juga 1, 0. 1, 0 and 0, 1. So bila x 0, y sama dengan, bila x 1, y sama dengan 0. So ada 2 titik. So dapatlah ini adalah dia punya curve C. Okay. So this is the respective curve. Okay. So dia punya gerakan adalah satu here. So dia gerak ke atas sebab case dia yang ini T sama dengan 0 dan T sama dengan 1. So gerakkan ke atas S from T equal to 0 to T equal to pi per 2. That's why dia punya arah dia punya curve dia adalah ke atas. So this is the circular X. Okay. The circular X of C. So kita nak dapatkan dia punya integration for this case. So boleh salin dulu. Kita tengok how to use the line integral to solve for this integration. Done.
Done, sir.
Done. Okay. So kita tengok how to prove this one. Okay. New slide. Okay, this is the curve yang kita dapat tadi. And then kalau awak tengok dia punya integration ada dua. Okay. Yang ini terhadap dx and this one terhadap dy. So dia sebenarnya integration kan kalau tambah kita boleh pisahkan kan. Integration over the curve C 2xy dx plus integration over the curve C x squared plus y squared dy. Okay. So kalau tengok yang ini dia ada dx, dia ada dy. So kita boleh gunakan dan y sama dengan function of t, x also it's a function of t. So kita boleh use line integrals. Okay. So from here salin balik soalan. Integration over the curve C 2xy dx plus integration over the curve C x squared plus y squared dy. So given okay, given x of t equal to cos t and y if of t equal to sine of t. Okay. So from here, we will like to find by using the line integral. By using the line integral. So akan dapat integration over the curve C, function of xy dx equal to integration over the curve AB f function of xt yt x prime t dt. Okay, this one. And another one, we have integration over the curve C, gxy dy equal to integration over a to b, g x of t, y of t, y prime t dt. So sesuaikan dengan soalan, you have this one as your dx, this is your dy. So this is dx, so this is your dy. So this one will be your f of xy and this one will be your g of xy. Okay. So from the theorem of line integral, so you are going to have f of xy sama dengan 2xy. Okay. And then okay, x of t sama dengan cos t. Dan x prime t akan sama dengan negatif sin t. Okay. And your gxy equal to x squared plus y squared. Okay. Y of t equal to sin t, y prime t sama dengan cos t. Okay. So from here kita akan ada this one. Okay. Nak sesuaikan dengan yang ini. So ada f x t y t. Okay. F of x t y t gantikan 2xy sama dengan 2, x adalah cos t, y is sin t. Okay. So tu sahaja. The same goes for this one. X squared plus y squared nak jadikan dia sebagai function terhadap t. So boleh salin dulu dan kita tengok. Macam mana dia punya ni. So kalau gantikan dalam GXT, okay, GXY sama dengan X squared plus Y squared. So G of XT YT akan sama dengan cos T kuasa 2 tambah sin T kuasa 2 equal to cos squared T plus sin squared T sama dengan 1. So masukkan all this information that you have find in this one. Yang ini and also this one dekat dalam yang ini. Okay. No. In here. Yang ini gantikan dekat dalam ni. This one masukkan dekat dalam that one. So kita tengok nanti macam mana nak dapatkan the what we call it, the integration by using line integral. So yang nak salin boleh salin dulu. Sekejap lagi saya nak tunjukkan how to find the integration using line integral. Adik. Done. Okay, so if I think everyone is done with that one, so let's take a look how to solve the integration. We will solve one by one. So saya nak selesaikan yang f function dulu. Dah ni? Senyap je duduk dah ni. Hui.
Dah.
Okay, good. So saya nak selesaikan the first one, that is the f function. Okay. So integration over the curve C, f of xy dx. it will be equal to integration over the curve A to B, okay, f of x t y t x prime t dt. So sama dengan integration daripada 0 sampai pi per 2 cos t sin t, and your x prime t is negative sin t dt. Okay. T is between 0 sampai pi per 2. Okay. That is why akan dapat that one. Okay. So dia akan sama dengan solving for that integration, it will be equal to negative 2 kita keluarkan 0 from pi over 2 cos t sin squared t dt. So integration with respect to this one. Okay. So we will make use of the integration by substitution. Okay. By using integration by substitution. Okay. Integration by substitution, meaning that taking your u sama dengan sin t. Okay. Du over dt equal to cos of t. So du equal to cos t dt. So you get the term of cos t dt, and this is your u squared. Okay. So this one akan sama dengan negatif 2 integration kosong pi per 2 u kuasa 2 du. So negatif 2 u kuasa 3 kosong sampai pi per 2. So equal to negatif 2 per 3. U kuasa 3 is sin kuasa 3t kosong dan juga pi per 2. So sama dengan negatif 2 per 3, 1 minus 0. So dapat jawapan dia negatif 2 per 3. Okay. So itu untuk first part. That one. Untuk 2xy. So that is the first part. That is your f of xy. Then cuba the second part, g of xy. So this is your first and this is your second. So ini yang first. So the second one. Integration over the curve C, x squared plus y squared dy. Integration over the curve C, sin cos squared cos squared t plus sin squared t darab dengan y prime t. Y prime t is cos t dt. Okay. This one daripada integration gxy dy integration a to b g x t y t y prime t dt. Okay. So masukkan dekat dalam that one. So cos squared plus sin squared, this one become 1. So it will be integration over the curve C cos t dt. So dia akan jadi integration t daripada 0 sampai pi per 2. Okay. Sama dengan sin of t 0 sampai pi per 2. Sin pi over 2 minus sin 0. So you get the answer sama dengan 1. Okay. Hence, integration over the curve C 2xy dx plus x squared plus y squared dy, it will be equal to negatif 2/3 tambah 1. Dapat jawapan 1/3. Dapat So that is dia dapat semua?
Dapat Doktor.
Okay. Done? Belum?
Done, sir.
Okay, yang lain done? Soalan? Dia dalam chapter ni, dalam subjek engineering maths 2 ni memang kena nama kau punya integration bagai tu kena ingat betul-betul lah. All the integration rule, how you do the integration of trigonometric function, because we deal a lot with such thing. Okay, integration and differentiation. Paling banyak integration lah tapi. So, nanti insyaAllah kita tengok, saya nak Dr. Kiai dah bagi nota EMT. Kita tengok macam mana nak merge kan, sesuaikan. Because in EMT, the vector notation use a difference notation, not I, J and K. So that should be fine. Okay, done lah this one. So this is the line integral. Awak pisahkan sahaja dia punya this one for the first part and second part. Tengok dia ada dx, dy. So nanti later on by using Green's theorem, Stokes theorem, divergence theorem, we will make use of those theorem to simplify the line integral. Meaning that calculation jadi much more simple rather than using all of this pisahkan for two parts. Okay. So this is an example of line integral. So the reversal orientation. Kita kira tadi kita dapat jawapan dia sama dengan 1/3. Okay, we get the integration over the curve C is equal to 1/3 with your curve is here. Okay, bergerak daripada atas ke bawah, daripada bawah ke atas. This is your X and this is your Y. What if the curve will be like this? Okay, macam mana kalau curve dia ke bawah macam gini? So daripada sini kita akan tengok dia punya reversal of orientation. There is another theorem. If C is a smooth parametric curve and if a smooth change of parameter is made that reverse the orientation of the curve, then for any integral of C, the two sets of parametric equation will produce the value that are negative of one another. Meaning that kalau kita, let's say for that for this example, if you have X dan Y daripada bawah ke atas, what if, okay, it's reverse, meaning that the movement will goes from atas ke bawah. Okay, it will produce value that are negative of one another. So kalau tadi awak buat dapat dia punya answer equal to positive 1/3. This time around you still get the same answer but it will be negative 1/3 to denote that the curve move from upward to downward. That is follow the clockwise. If it is anti-clockwise, then you get the positive value of the line integral. Okay, so let's take a look into an example. Okay. So sama juga soalan dia. Evaluate integration over the curve C for 2xy dx plus x squared plus y squared dy over the circular x C given by x equal to t, y equal to square root of 1 minus t squared, by which t taking the value between 0 and 1. Okay, so let's take a look in how you are going to solve for this particular question. Okay, so first we want to drawing the curve. Okay, drawing the curve, you are going to have t sama dengan kosong, x akan sama dengan t sama dengan kosong, y sama dengan 1 tolak t squared sama dengan set 1 tolak 0 sama dengan set 1 equal to 1. So at t equal to 0, x sama dengan kosong, y sama dengan 1. And another point, T equal to 1, X equal to T akan sama dengan 1. Y sama dengan set 1 tolak T squared. That is set 1 tolak 1. Set of 0 equal to 0. So at T equal to 1, X akan sama dengan 1, Y akan sama dengan 0. So using this information, we will draw the curve. Okay, draw the curve. So if you draw the curve, we have X dan juga Y. So X kosong, Y sama dengan 1. Ni pada T sama dengan 0. And then X sama dengan 1, Y sama dengan 0. This one at T sama dengan 1. So dia bergerak of course lah daripada T sama dengan 0 kepada T sama dengan 1. So the line will move from here. Jadi ke bawah. Okay. So this is the circular axis that move downward. Okay. Then kita nak dapatkan dia punya integration for this one using all of the information given. Okay, boleh salin dulu and boleh try. So cuba guna yang tadi. That is, this is your F, X, Y, and this is your G, X, Y. Yang ini X, T awak sama dengan T, Y of T sama dengan set 1 tolak T squared. So gunakan the line integral. So by using line integral, how we are going to solve for this one? Dan, what is fun? Kalau Dan angkat tanda bagus beramai-ramai. Baru seorang. 2, 3. So for this one, you are going to have your f of xy sama dengan 2xy. Okay. F of x t y t akan sama dengan 2, x sama dengan t darabkan dengan t, y sama dengan set 1 tolak t squared. So 2t set 1 tolak t squared. Xt equal to t x prime t sama dengan 1. Okay. That is for your f function. Then trying the same for the g function. So gxy akan sama dengan x squared plus y squared. G of x t y t akan sama dengan t kuasa 2 tambah set 1 tambah c squared kuasa 2. So jadi t kuasa 2 plus 1 tolak t squared. So it will be equal to t squared 1. Jadi itulah t squared plus 1 minus t squared. It will be equal to 1. Okay. Then from here awak punya g function is gy of t sama dengan set 1 tolak t squared. That is 1 tolak t kuasa 2 kuasa 1/2. So y prime of t akan sama dengan 1 tolak t kuasa 2, 1/2 tolak 1, negatif 1/2 darabkan dengan kat dalam dia kita bezakan jadi negatif 2t. Okay. 1/2 kita keluarkan. Sama dengan 1/2 this one. So yang ini boleh dihapuskan. So you akan dapat y prime t sama dengan negatif t per set 1 tolak t squared. Okay. That is y prime t. So masukkan dalam integration over the curve C. This one akan jadi integration over AB f of x t y t x prime t dt plus integration from A to B g x of t y of t y prime t dt. Okay, that's it. So cuba masukkan. Semua information dah ada, you just substitute in the given equation. Okay. This is the first part and this is the second part. Yang ini 1, yang ini 2. So yang ini semua untuk first part and this all for the second part. So substitute in there, what will you have? Cuba try that one. Dan kita tengok sama-sama. Dan dapat tak jawapan dia negatif 1/3? Sama je dengan yang tadi. But we get the negative value as the orientation goes from upward to downwards. Dan this one.
Yes.
Okay, good. So kita tengok the first one. Okay. So the first one, okay, the first one, the first part, okay, integration over the curve C f of xy dx equal to integration over the curve C 2 xy dx. So equal to integrate daripada kosong sampai 1 untuk t, 2, x is t, y is set 1 tolak t squared. Okay, didarabkan dengan x prime t. This one from integration from a to b f x of t y of t x prime t dt. So xt awak sama dengan t, x prime t dapat sama dengan 1. Okay, so integrate with respect to dt. So you will get this one from 0 to 1, 2t set 1 minus t squared dt. So 2 kita boleh keluarkan, integration from 0 to 1 set of 1 minus t squared dt. Okay, so from here taking, okay, u sama dengan t kuasa 2, du over dt sama dengan 2t. So du per 2 sama dengan t dt. So the term of t dt, you get the term here, t dt. Okay, so from this one, it will become integration over 2, 0 to 1, set 1 tolak u du per 2. Okay, so yang ini boleh hapus, this 2 dengan this 2 boleh dihapuskan. It will become integration 0 to 1 1 tolak u kuasa 1 per 2 du. So dia akan sama dengan 1 tolak u kuasa 3 per 2 negatif 1 from 0 to 1. So negatif 2 per 3 1 tolak u kuasa 3 per 2 from 0 to 1. Negatif 2 per 3 1 tolak t kuasa 2 kuasa 3 per 2 0 to 1. So dapat negatif 2 per 3 0 minus 1 sama dengan 2 per 3. Okay. That is the first part. So the second part, integration over the curve C, gxy dy. So integration over the curve C, x squared plus y squared dy. It will be integration from 0 to 1, t kuasa 2 plus square root 1 tolak t squared kuasa 2. Okay. Didarabkan dengan this one menggunakan konsep A to B G x of t y t y prime t dt. So tadi kita punya yt set 1 tolak t squared. And then kita dah dapatkan y prime t sama dengan negatif t over set 1 minus t squared. So masukkanlah dekat dalam tu. Y prime t awak adalah negatif of t set 1 tolak t kuasa 2 dt. So yang ini tadi dah hapuskan, tinggal 1. So dia akan sama dengan negatif integration 0 to 1 t over set 1 minus t squared dt. Okay. So by using substitution as well, taking u equal to t squared, okay, du over dt equal to 2t. So du per 2 equal to t dt. So the term t dt kita dapat dekat sini. T dt. Okay. So it will be negative 0 to 1 1 per set 1 tolak u du per 2 sama dengan negatif 1 per 2 0 to 1 1 tolak u kuasa negatif half du. Settlekan that integration. Integrate yang ini sama dengan yang tadi. Dapat negatif 1 per 2 okay, 1 per 2 1 tolak u kuasa 1 per 2 per 1 per 2 0 and 1. So yang ini boleh hapus. This one. So gantikan lah. Gantikan, dapat jawapan sama dengan this one will become sama dengan 1 tolak t kuasa 2. Kuasa 1 per 2, 0 and 1. So dapat jawapan sama dengan negatif 1. Negatif 1. So dapat 2 per 3 tolak 1. Dapat jawapan akhir akan sama dengan negatif 1 per 3. So, boleh salin dulu. Saya pergi toilet jap. So, kalau kita tambahkan kedua-duanya, so if we substitute integration over the curve C f of xy dx plus integration over the curve C 2xy dx plus y squared dy. Tadi kita dah kira this is the first part and this is the second part. First part tadi kita dapat 2/3 tolak 1. So dapat negatif 1/3. Itu jawapan dia. Okay. So answer equal to negative 1/3 due to clockwise direction. Tetap jawapan dia tetap sama 1/3. The difference is only you have the negative value for this one punya integration. Okay, dapat semua? Okay, done. Hui, done.
Dah okay.
Okay. Okay, kita tengok kepada the next one. Okay, so line integral over piecewise smooth curve. Okay, so line integral, dah previously kita tengok integration over the curve, satu curve C. Okay, what if you have the piecewise smooth curve? Okay, so line integral definition can extend it to curve formed by infinitely many smooth curves. That is, you are having curve 1, curve 2 up until curve n that's join end to end. and this is known as the piecewise smooth. So the line integral over a piecewise smooth curve C, it will be the sum of the integration over the pieces. That means if we want to find the integration over the curve C, we will add up for each pieces of the curve C1 plus integration over curve 1 plus integration over the second curve plus all everything up until integration over n curve. Okay. So for example, for the first one, awak ada 3 curve C1, C2 and C3. So we find the integration over this curve. And then for the second one, you have 2 curve as well. First moving from here and then they start naik. This one become 2 curve. So nak dapatkan integration over the curve C equal to integration over curve C1 plus integration over the curve C. So yang ini akan jadi integration C1 plus C2 plus the curve of C3. So buatlah line integral untuk setiap satu persatu. That is a bit barok jugalah. Okay. Just say for example you have this type of curve. So kena buat satu persatu dia punya line integral for this one. Okay. So this is an exercise you can try by yourself if you want to find the curve of x equal to t, y equal to t squared and dapatkan setiap integration over this one. This sebenarnya lebih kurang dengan yang tadi. Satu curve je. So this is your f of xy. This is your g of xy. This is your xt. This is your yt. So you can try this one by yourself. Okay. Sebab saya tak ni lah. Saya tak buat this one. You can try by yourself. It's the same as previously. So buat dia punya integration. The next one kita tengok vector notation. So yang kita buat ni tadi semuanya scalar. Okay. This one yang awak buat ni tadi all are scalar. You don't have the I, J dan juga K. So kali ni kita nak dapatkan vector integration terhadap curve tapi dia untuk vector function. So you have I, J and K. So how we are going to solve for this one? So from here, how we are going to solve the vector notation for that particular example? Okay. So this one, okay, vector notation for line integral. So for the vector function, you have the direction and also the magnitude. So it will be helpful to express the line curve in the vector notation, that is integration over the curve C for f with respect to the x plus integration over the curve for g function with respect to dy. So we will introduce the vector value function by which f is function of xy will be equal to f of x1i plus gxyj. Okay, the vector notation. And we will express the curve x equal to xt and y equal to yt in terms of the position vector. That is, daripada xt dan juga yt ni kita akan dapatkan dia punya position of the vector. Rt equal to xti plus ytj. Okay. So from here, the line integral will become integration over the curve C fxy dx plus gxy, and this one in terms of vector function akan dapat the integration can be simplified into integration over the curve C for vector f with respect to dr. Okay, so dr meaning that tadi awak ada rt, okay, equal to xti plus ytj. So dr is r prime t, that is rt over dt. Okay, so this is actually r prime t, first order derivative of vector function. So x prime ti plus y prime t j. So it will be equal to integration from a to b for vector f. Still gantikan x dan y term dengan xt dan juga yt, and dr over dt, this is the first order derivative of the vector function r prime t. So we will solve the integration of the vector value function by using this theorem of line integral for vector function. So let's take a look into example. Saya nak tengok ni dulu, boleh tengok? Saya bagi 1 minit. Okay. So find the work done. Okay. Kerja yang dilakukan. Work done. If a particle move from negative 2, 4 to 1, 1 along the parabola y equal to x squared, subject to the force of fxy equal to x cubed yi plus x minus y j. So this is the vector f. And then you can take a look this one from negative 2, 4 to 1, 1. That means this is your x. Okay. X daripada negatif 2 kepada 1 dan this is your y. Y daripada 4 kepada 1. Okay. So kita nak menggunakan the theorem of integration. We want to use integration over the curve C for vector f x y d dot, this is having the dot product, dr equal to integration from a to b f of xt yt dot dr over dt. Okay, with respect to dt, by which this is r prime t. Okay, so from here, so we want to make use of this vector function. So awak ada vector r, dia ada bagi tak? Dia hanya bagi y sama dengan x kuasa 2. So what is vector r? Okay, what is vector r of t? So dia tak ada bagi, dia just bagi given y sama dengan x squared. So kita known that rt equal to xti plus ytj. Okay, so in this case, assume, not assume, let. Okay, in this case, let xt equal to t. So y of t akan sama dengan x kuasa 2 sama dengan t kuasa 2. So vector r of t akan sama dengan ti plus t squared j. Okay, yang mana t berada antara negatif 2 sampai 1. Why negatif 2 sampai 1? Because t equal to x dan x is daripada negatif 2 sampai 1. Okay, from this one. This one. X is from -2 up until 1 and Y is from 4 up until 2. So this is your vector R and kita nak dapatkan vektor F pula. So boleh salin dulu. So F of XY sama dengan X cube YI X minus YJ. So gantikan dengan sebutan T. Jadi apa vektor F? Okay. Vector F in terms of T. That is Ft sama dengan apa? By using this information. Dan apa vector F? What will you have for the vector of F function?
T kuasa 5I.
Betul?
Tambah dengan T tolak T kuasa 2J.
Yep, betul. Okay. Woman always right. So thank you Nadia. So betul jawapan Nadia. Okay. So gantikan sahaja X sama dengan T dan Y sama dengan T kuasa 2. So you will have T kuasa 3 darab dengan T kuasa 2. I. Okay. Plus T minus T kuasa 2 J. Where it will become T kuasa 5I plus T minus T squared J. Okay. So that is the vector F of T. So dah ada semua information dia. Kita akan masukkan dekat dalam this one. Okay. Kita akan masukkan dekat dalam yang ini. So masukkan dekat dalam ni. Kena dapatkan this one lagi satu. R prime T. So R prime T sama dengan I tambah 2T J. Bezakan terhadap T. So masukkan this one dekat dalam ini, R prime T dekat dalam ni. So dapat apa? Dot product. And this is the dot product. That means kalau dot product dia takkan ada I, J dan juga K. So dia dapat tak jawapan integration? Kan dapat jawapan dia sama dengan 3. Slide ni done So the work done, kita substitute everything. The work done equal to, it will be equal to integration over the curve C f of xy dr. Okay, that is equal to integration from A to B f of x t y t dr over dt multiply with dt. Okay, dot product by which this is r prime t. So kita ada vektor r akan tadi sama dengan t I plus t squared j. So r prime t equal to I plus 2t j. Okay, so substitute in the given equation. So t pula berada antara negatif 2 dan juga 1. So it will become integration from negatif 2 kepada 1 t kuasa 5i plus t minus t squared j dot product dengan I tambah 2t j didarabkan dengan dt. So this is the dot product, meaning that ni darab dengan ni and this one multiply with this one. So equal to negatif 2 sampai 1 t kuasa 5 tambah dengan 2t kuasa 2 tolak 2t kuasa 3 dt. So integrate t kuasa 6 ter 6 tambah 2t kuasa 3 per 3 tolak 2t kuasa 4 per 4 negatif 2 sampai 1. Okay, so it will become 1/6 tolak 2/3 tolak 1/2 tolak 32/3 tambah 16/3 tolak 32/4 sama dengan 3. So the work done equal to 3 unit. Dapat? So this is the integration over the curve involving the vector function.
Satu per enam tu tolak dengan 2/3 tu, ke tambah?
1/6 tolak 2/3. Mana? Tambah. Okay, thank you. Salah type. Tapi woman always right. Tolak ah. Tambah betul lah. Tambah. Dapat Helen? So kita tengok lagi satu example. Lagi dua example. Tiga. Okay, anda cuba buat next exercise tu. The extended vector notation for 3D. Oh tapi tak apa, kita tengok dulu. Sorry. Dan kelas. This one. Yang itu dia dot product That's why kita darabkan sesama dia. This is dot product. So kalau dot product, I darab I dot I. Okay. I dot I akan sama dengan 1. I dot J sama dengan 0. J dot J sama dengan 1. J dot I sama dengan 0. That's why in finally you get the answer. There is no notation of I, J and K anymore. Just dia punya apa nama dia? Hasil darab. Kita darabkan dia directly. Okay, done. So let's take a look into the vector notation. Yang tadi kita tengok untuk I, J dan K. What if we have 3D space? That is, you have I, J and also K. So from here, the line integrals can extend it to space such that the integration, rather than having the vector of x, y, you are going to have vector of x, y and z. Okay. So sama je, cumanya kali ni you have the term of z of t. So integration over the curve C for the vector f x of y z dr dot dr, it will be equal to integration from a to b f of xt, yt, zt having the dot product. So this is dot product, okay, of drt, that is r prime t. So vektor r awak akan jadi okay, so sebelum ni your vector rt equal to xti plus ytj plus z of t k plus ytj. So this time around vector r awak akan jadi 3 term. Xt plus yt plus zt. So r prime t, the first order derivative equal to x prime t I plus y prime t j plus z prime of t k. Okay, that is the notation for the vector function. Okay, dapat So daripada sini, let's take a look into example. What if you have f is a vector function of x, y and z? Okay, so for this one, let's take a look into this example. So find the integration over the curve C for vector f dr, where f sama dengan zi plus xj plus yk and c is a curve with vector r equal to sin ti plus 3 sin tj plus sin squared tk. So kali ni vektor f ni pula yang dia bagi hanyalah z, x dan juga y. Dia tak bagi pun x sama dengan apa, xt sama dengan apa, yt sama dengan apa, dia tak bagi. So kita nak dapatkan vektor f in terms of t. Okay, so kita tengok daripada sini. rt equal to sin ti plus 3 sin tj plus sin squared tk. So this is your x of t and this is your y of t and this is your z of t. So daripada sini kita dapat xt sama dengan sin t, yt equal to 3 sin t and your z of t sama dengan sin squared t. Okay, so vector f of x, y, z sama dengan zi plus xj plus yk. So z akan sama dengan sin squared ti plus x is sin tj plus 3 sin tk. Okay. So this is vector f in term of t. Okay. And kita nak dapatkan lagi satu f dan juga rt, drt. So rt sama dengan r of t T equal to sin Ti plus 3 sin Tj plus sin square T. Okay. So R prime T, bezakanlah sin. Bezakan sin akan dapat cos Ti. Okay. Bezakan sin lagi dapat 3 cos Tj. Bezakan sin square Tk akan jadi tambah 2 sin T cos Tk. Okay. So dapat T daripada 0 sampai pi per 2. So this one having dot product with this one. Kita nak masukkan dekat dalam yang ini. So dia punya T 0 sampai pi per 2. So dapatkan dia punya dot product. Dot product. For these two. What will you have? Cuba dapatkan the dot product. And then give me the answer for that one. Okay, done So kita cuba dapatkan, so saya tulis balik dekat next slide. Vector F in term of T akan dapat tadi sama dengan sin squared Ti plus sin Tj plus 3 sin Tk. Okay. And R prime T tadi kita dapat cos Ti plus 3 cos Tj plus 2 sin T cos Tk. Okay. So integration over the curve C F dr equal to integration T daripada 0 sampai pi per 2 sin squared Ti plus sin Tj J plus 3 sin T K. Having the dot product with cos Ti plus 3 cos Tj plus 2 sin T cos T K. Okay, so I darab I, J darab J, and K darab K, the dot product. So equal to integration from 0 pi over 2 sin squared T cos T plus 3 cos T sin T plus 6 sin squared T cos T dt. Okay. So yang ini dua having the same term. Okay. It will become integration 0 pi over 2 7 sin squared T cos T plus 3 sin T cos T dt. Okay. So, sama dengan 7 keluarkan 0 pi over 2 sin squared T cos T dt plus 3 keluarkan from 0 up until pi over 2 sin T cos T dt. So, using integration by substitution, taking U sama dengan sin T du over dt equal to cos T. So, du equal to cos T dt. Okay. U equal to sin T sama juga. Du over dt equal to cos T. So, du equal to cos T dt. Okay. So, by using substitution, 7 0 pi over 2 U kuasa 2 du plus 3 0 pi over 2 U du. So 7 U kuasa 3 per 3 plus 3 U kuasa 2 per 2. 0 pi over 2. So gantikanlah. 7 per 3 U is sin T 0 pi per 2 plus 3 per 2 kuasa 3. Sin kuasa 2T 0 pi per 2. So gantikan dapat 7 per 3 plus 3 per 2. So 23 per 6. So this is the final answer. 23 over 6. So dapat kelas? So that is the vector, the line integral involving the vector function. Okay. So ada lagi 2 exercise. Saya bagi awak jawapan akhir. Besok kita tengok kepada Green's theorem. Parametric forms of vector function, and then we have the Green's theorems. Okay. So another 2 example in the slide. You can try by yourself. I will snap the picture for the, what we call it, for the full solution. You can try by yourself. So I have put the example in the group, the solution for another 2 example. Ada soalan tak so far? So far so good. Hui.
So far so good, Doktor.
Okay. Ada soalan tak? Tak ada. Sebenarnya nampak macam susah apa nama vector calculus ni, tapi sebenarnya much more simple compare dengan the rest yang awak belajar. Okay. So saya akan settlekan marking hari ni, hopefully settle marking. Nanti saya key in dalam markah and then kalau dah siap saya akan display dekat dalam group as well. I will share in the group and dekat dalam portal. Sebab tempoh tarik dia ni before 31st, right? So done for this part.
Dah, Doktor.
Dan ada soalan? Tak ada. Ada lagi 2 exercise tu you may try by yourself. Okay. And then so kalau tak ada apa-apa that's it for today. Besok kelas macam biasa pukul 9 sampai pukul 11. We will take a look into the continuation of these vector fields. Okay, kita ada Green's theorems and also piecewise function for the vector. The piecewise for the parametric equation for the vector function. Okay. So that's it. Thank you, class. Have a nice weekend and stay safe.
Thank you, Doktor.
Welcome.
Thank you, Doktor.
Thank you, Doktor.